This week at NASA. Expedition 24 flight engineers Doug Wheelock and Tracy Caldwell Dyson completed the first spacewalk to replace a failed ammonia pump module on the International Space Station.
Okay, it's full forward, Oscar.
Awesome. Sweet.
The 8-hour, 3-minute excursion fell short of removing the failed pump module due to a leak in the fourth of 4 ammonia line connectors.
The team is in great spirits. They did a great job today. It's disappointing that we didn't get further along in the plan, but the system is stable and the team is ready to take on the challenge of rescheduling the EVAs and getting back out there to complete the job.
The completion of the process will most likely require at least 2 additional spacewalks. Saturday's spacewalk was the longest expedition crew EVA in history and the 6th longest in the history of human spaceflight. NASA and the European Space Agency, ESA, have joined forces and resources to explore the Red Planet.
Recognizing missions cost a lot more to do the best science, and the economic situation isn't the best it could be, it's time for us to stop competing with our major partners like the Europeans and start working together.
In 3 separate robotic missions, the partner agencies will study the possibility of past life on Mars, as well as test communications relays and explore other geochemical and biological mysteries. The first, in 2016, will search for trace gases in the Martian atmosphere that could indicate the existence of life on the Red Planet. A second, in 2018, will send 2 rovers to the Martian surface. Both missions will lead the way for a third in the following decade that'll return to Earth a sample taken from the Martian surface.
The driving reason behind an ESA-NASA collaboration is to build our capabilities to return samples from Mars in the 2020s. We call it a campaign because it could cover 2 or maybe 3 launch opportunities to be able to set the infrastructure on the surface of the planet, get the samples back off of the planet, and return those to Earth safely.
Engineers at the Jet Propulsion Laboratory are getting their athlete some exercise. Athlete, for all-terrain hex-limbed extraterrestrial explorer, is a working prototype of a robotic rover that can transport habitats and other cargo on the surface of the Moon or Mars. The half-scale vehicle that stands 15 feet tall has been stretching its 6 legs on a series of extended drive tests on the long dirt roads adjacent to JPL.
The athlete is actually programmed to adjust the height of each leg so that it keeps an equal amount of weight on each wheel. And so that means as it's going over small hills and through rolling terrain, it'll actually conform to the hills and valleys and make sure that the robot's always got an equal amount of force on each tire. For rougher terrain, like if there's lots of obstacles like rocks or if it gets really loose and sandy or really steep, athlete can actually start walking.
The engineers want to test athletes' ability to meet a NASA milestone of traveling at least 25 miles under its own power in 14 days or less. The robot's top speed is about 1.25 miles an hour. The official demonstration is slated to begin next month during NASA's DRATS, or Desert Research and Technology Studies project in remote northern Arizona. This new composite image from the Chandra X-ray Observatory, the Hubble Space Telescope, and the Spitzer Space Telescope shows 2 colliding galaxies more than 100 million years after they first impacted each other. The continuing collision of the antennae galaxies, located about 62 million light-years from Earth, has triggered the formation of millions of stars and clouds of dust and gas in the galaxies. The X-ray image from Chandra shows huge clouds of hot interstellar gas that have been injected with rich deposits of elements from supernova explosions. This enriched gas, which includes elements such as oxygen, iron, magnesium, and silicon, will one day be incorporated into new generations of stars and planets. A half-dozen students participating in NASA's Inspire summer internship program at the Dryden Flight Research Center are learning firsthand about the start-to-finish life cycle of flight testing experimental aircraft. The students worked in teams to flight test a large remote-controlled model airplane. They analyzed the performance of the aircraft using data collected on those flights. NASA's Inspire provides future engineers with project experience prior to entering their senior year of high school or their first semester of college. 50 years ago, NASA launched its first communications satellite, Echo 1. Made from mylar polyester film and measuring about 100 feet across, the balloon-shaped spacecraft was designed as a passive communications reflector for transcontinental and intercontinental telephone, radio, and television signals. During orbit, a special recorded message from President Dwight Eisenhower was bounced off Echo 1 and picked up by radio operators across the nation.
This is President Eisenhower speaking. It is a great personal satisfaction to participate in this first experiment in communications.
Echo 1 re-entered the atmosphere on May 24, 1968.
Ignition and liftoff of the Atlas V rocket with MRO.
5 years ago, NASA's Mars Reconnaissance Orbiter was launched in search of evidence that water persisted on the surface of Mars over a prolonged period of time. Previous Mars missions indicated that, at some point in the red planet's history, water flowed across its surface. Throughout the years, MRO has continued to analyze minerals, look for water, trace the distribution of dust in the atmosphere, and monitor Martian weather. And that's This Week at NASA. For more on these and other stories, log on to www.nasa.gov.